Okay, so here at the top, we are filling in the blanks for a definition. Today we're going to be doing dilations. So a dilation is a transformation that alters the size of the geometric figure, but does not change its shape. So, unlike our translations, rotations, and reflections, where it stayed congruent, meaning same size, same shape, here it's still the same shape, but it won't be the same size. So this dilation is, unlike congruent, we call it a similarity transformation. Okay. And then they give us two examples of a dilation here. It says in the figure over here, the measure of C, so C is my point of dilation, to a point on XY is twice the distance from C to a corresponding point on AB. So they're saying from C to A is half what it is to X, or X is double what it is to A. And that can be found using this information right here. CX is equal to 2 times CA, or CY over here is equal to 2 times the length of CB. In this transformation, AB with a center at C and a scale factor of 2 was enlarged to become XY. So since it was double in length, we say that its scale factor is 2. Okay? So this point here is what we call the center of dilation. And clearly, if your scale factor, which here was 2, we're going to call our scale factor K. If K is greater than 1, then your dilation should be an enlargement. Okay, and then over here, it says that the figure coming from your dilation point C to a point on PQ is 1/3 of the distance from C to some point on AB. So now they're saying that CP is 1/3 of AB. So now they're saying that you're going from small to big, from big to small, so your CP is 1/3 of CA. Okay, that would mean that since my center is at C, if your K is between 0 and 1, we don't want to say less than 1 because that would imply that our scale factor could be negative, and it's not going to be negative. But anything between 0 and 1, then the dilation should be a reduction. All right, so keeping this information in mind, they then give us two examples. They give us a scale factor, and they give us a point of dilation, and they want us to come up with the dilations. All right, so for example 1, they tell us our K, or our scale factor, is 3/4, and that C is our center. Okay, so if my scale factor is 3/4, is my new figure going to be bigger or smaller? Smaller. It's going to get smaller. Okay. All right, so what we're going to do is we are going to measure how far it is from C to X. Okay, so I'm going to draw in just kind of like a dotted line from C to X. It's just an imaginary line. There's not actually one there, but for measurement reasons, we'll put one in. Okay. You could do the same from your C to your Y. Okay, so let's start with the CX. We are trying to find some new point X, like you guys said, that's going to be smaller or closer to the center of dilation, right? So we are looking to find some x prime points. So we'll call it Cx prime. Okay, well, according to our rule from up above, whatever you want to change your new piece into, you multiply it by your scale factor. So I would multiply 3/4 times the original line, which is Cx. Okay, so really I just need to multiply 3/4 by the length of Cx. So we're going to measure the length of Cx in millimeters. So take your ruler, measure here. Mine looks to be just slightly past 35, so probably at 36. So we would put in 36 millimeters here. Okay. And what is 3/4 times 36? What is it? 27. Very good. So my Cx prime should be 27 millimeters. Okay, that means that I'm going to take my ruler, come back over here, and I'm going to put a point at 27 millimeters on that dotted line that we created. So that'd be right about here, and I'll call that x prime. Okay, now I'm going to do the same thing for y. So I'm looking to find cy prime. So that means I'm going to have to multiply my scale factor times the original cy. So I'm going to take my ruler and in millimeters measure that out. That's just under 45. So I'd say that's probably 44 would be my best guess there. And what is 3/4 times 44? 33. Okay, so now I'm going to take my ruler. I'm going to measure from C and put myself a point at 33 millimeters. And I'll call that point y prime. And our job was to come up with the new xy. So I'll connect my points x prime and y prime. So the length of x prime, y prime should be 3/4 the length of xy. Okay. All right, so now that we know the process, let's do another one. Okay, this next one says that our scale factor is 3, right? So is this one going to get bigger or smaller? Bigger. Okay, so we're going to use the same process. So I'm going to look for my Cx prime first. Okay, so I'm going to go ahead and draw in some dotted line over here. This time, remember that it needs to go past my point because we're saying it's going to get bigger. Okay, and then same for y. Okay, so let's see here. To find X prime, that means we need to multiply 3 times the original Cx, right? So I take my ruler, and in millimeters, I'm going to measure how long this segment is from C to X. What does that look like to you guys?
Are we measuring from the inside of the circles or the outside?
You should put your 0 in the middle. Mine's looking like it's right at 15. That middle line is hitting right in the middle of that dot. So I'm going to put 15 there. So I have 3 times 15 millimeters. Okay, so what is the length of my Cx prime? What is it? 45. Okay, so that means I need to measure over here on that perforated line that we created and put myself a point at 45. So right here is my x prime. All right, now I've got to do the same for y. So I'm looking for cy prime, which we'll find by multiplying 3 times the original cy. Okay, this one looks to be about the same size. So we'd have 3 times our 15 again. So again, 45. So I come over here. I'm going to measure out to 45. That's now my y prime. And then my last step is to connect those 2 points there. All right, and then the length of x prime, y prime should be approximately 3 times the length of xy. All right, so real quick, before we move on to the next page, what do you guys notice about these 2 segments that we just created? What kind of lines did that, as well as the one in the example above, look like? What kind of lines? Parallel lines. Okay, so they should be, as long as we made our markings correctly, you should be able to make the statement that xy is parallel to x prime, y prime here, and the same statement should be able to be made down here. Okay. All right, so if you will flip it over onto the back, now we're going to look at some figures that are given both the original and the new of the dilation, and we're going to come up with the scale factor. All right, so on number 2, it says determine the scale factor used for each dilation with a center C. The dilation image in the figure is shown with a dotted line. Okay, so the dilation image, that would mean that makes that the new, right? So whenever you're trying to come up with your scale factor, you always are going to put new over old. Or remember, we call those image and pre-image. Okay. All right, so it says the image is the one with the dotted line, right? So on figure A, is the dotted one bigger or smaller? Bigger. So that would mean my scale factor should be something large, right? Something bigger than 1. Okay, so I have to put new over old when I find this scale factor. All you really need to do is find 2 measurements and compare them. So for example, I could say that I know that this side over here is how many units long? 5. And this side over here is how many units long on the dotted figure? 10. And that would be enough information to set up a scale factor. So we put new, which we said is dotted, over old, which is the bolded one. So 10 over 5, what would that mean my scale factor is? 2. And like you guys said, that is an enlargement. All right. On B. Okay, again, I'm just trying to find a measurement for the figure. It looks like maybe down here at the bottom, that the bottom appears to be 2 units long, right? But that's for the dotted and the solid, right? Okay, so whenever I'm setting up my scale factor here, my new has a length of 2, and my original has a length of 2, right? So that simplifies to 1. So did any dilation happen here? No. All right. And then for C. Okay, so often we'll check the diameter or the radius if it's a circle and compare those. So let's see here. Inside of our circle, we've got a diameter of what for the dotted one? 2, okay? And that goes on the top of the fraction, right? And then what's the diameter for the larger circle? So we've got 1, 2, 3, 4 holes, and then we've got a half and a half, which is 5. And is 2/5 going to simplify? No, so that's my scale factor, 2/5. So this one showed a reduction. Okay. All right, number 3 says to draw the image MHS with a center of dilation at 0, 0 and a scale factor of 1/2. All that literally means for us to do is to go in and make these changes to these points. So if I am scaling this down by a factor of 1/2, then I have to multiply 1/2 times the x value of each one of these. So for m, that was 0, and the y value times 1/2, and our y value is 4, right? Okay, so what would our new coordinate m prime be? What's 1/2 times 0?
0.
And what's 1/2 times 4?
2.
All right, and then I have to do that for each point. So what's my h prime? Yes. And my s prime would be, oops, what is it? It's got to have 2 numbers.
Oh, it's -2.
Okay. Okay, so our original points, let's see here, were at 0, 4 was m. M prime we said is at 0, 2. Okay, and then we said that h was originally at -6, -2. And now it's at -3, -1. And s was originally at -4, +3, and now it's at -2, 1.5. So they did all come in a significant amount closer to the figure. All right, last one. Says find the resulting image of FROST after each transformation. Be sure that each transformation is dependent on the previous one. So here are the original points. We've got a point at 0, 2, that's F. At -2, 0, that's R. At -1, -2, that's O. And +1, -2, that's S. And then 2, 0 for T. All right. A says that we are going to reflect over the line y = 2. So I'm going to draw that line in. Y = 2 would be this line right here. All right? So starting with F. F is on my line of reflection. So is it going anywhere? No. So it stays 0, 2. All right, my point R. R is how many units below that line? 2. So its reflection would be 2 above. Okay? And where would that point be then? -2 what? 4. Okay, and then O. O is how many units below? 4. So now it should be 4 units above, which would put us at -1 what? 6. Okay. So -1 6. And then S is also that same amount of units below. So where would, oh, sorry, yeah, would be at 1 6. Yes, mine's out of order versus the notes here. Okay, so at 1 6, we have our S. And then lastly, where would T be? Where is T prime going to be moved to? Good. All right. Okay, then for B says we're going to make a translation. Each one of those points that we just plotted, we are now moving -3 or left 3 and down 2. So let's start with F. 1 2 3 1 2. So there's my F double prime, and it is at -3 0. My R, 1 2 3 1 2. My R double prime is now at -5 +2. My O double prime, 1 2 3 1 2, is at -4 4. And then my S is at 1 2 3 1 2, is where R prime actually was. So at 2 -4. And then lastly, T prime, 1 2 3 1 2, ends up right here as T double prime at the point -1 2. All right.
Wait, isn't S double prime -2 4?
S double prime -2 4. Yes, yes. Thank you. Sorry, I wrote it down wrong on here. -2 +4. Thank you. That's where I plotted it. I did not write that though. Thank you for catching that. Okay, and then C. C says to rotate 180. What's my rule for rotating 180? What do I change about the coordinates? We change the signs. So it's going to become opposite signs of the points I just had. So now it's going to be +3 0, +5 -2, +4 -4, +2 -4, and +1 -2. So 3 0, 5 -2, +4 -4, +2 -4, and +1 -2. All right, and then the last change says dilation of 2. How do I dilate it by 2? Multiply by 2. So if I multiply all my values from the points above by 2, oh, I didn't switch them, did I? So should have been, no, I had that right. Okay, yeah, -5. Okay. All right, so then these would be 6 0, 10 -4, 8 -8, and 4 -8. and 2, negative 4. All right. While you guys are plotting those last points, I'm going to go ahead and bring you your assignment. I don't know what it is. I guess we get distracted at the beginning of class in here because we always get so far behind that we're in class. I don't know how that is.